All right, so now we're on 4.2, and as you can see in this picture, it's one of those model questions, okay, where you have to say, okay, how was this thing assembled? So we have to be paying quite careful attention because sometimes it's not the most obvious to follow. So it says this diagram below, the diagrams below show a set of labeled assembly instructions, not in order. That's important. So it's not like they flow like this, which kind of makes sense if you look at the pictures, because this doesn't flow to that. To build a toy car with Lego blocks. So, first question says, study the diagram above and answer the questions that follow. 4.2.1. Write down the correct order of the assembly instructions to build the toy car using the letters A, B, C, D, and E. Okay, so I think we're going to start with that, okay, because there's nothing there. Then I think we're probably going to go to this, okay? Then we're going to flip it over. Then we're going to put some oaks on top. I don't know what those oaks are, but we'll put those there. And then we're going to do that. So that to me is the order. So it would go D, B, E, A, C. Okay, so it's kind of, if you wanted to swap these two around, I would probably allow that, okay? But it needs to end in this A, C. Okay, those two are non-negotiable, and it needs to start with needs to start with D, with this number 1 here. It needs to start with that. These two, debatable, but the other ones are kind of set in place. Okay, so 4.2.1, let me make sure you can see, is going to be, what did we say? D, B, E, A, C. D, B, E, A, C. Okay, good, let's keep going. It then says, which letter fits the instructions? Flip over the assembly part. Now, depending on how you answered, right, you would then have to look at that, because I went 1, 2, 3, okay? So in this case, for me, it would be E, because going from B to E, I'd have to flip it. If you said D, E, B as your order, then you would flip from E to B, right? So whichever you prefer, right, and whichever logical flow you used, I'm going to say E. But the memo also accepts B depending on what you did in the first question. So just be very careful to follow your own logic, because something that students often forget is that markers follow your logic. So even if you're not exactly according to the memo, they can still give you credit if it's logical, okay? Because sometimes when these papers are set, they don't always see everything that could be interpreted in different ways. So don't stress about that. Okay, it says, a can of Lego blocks contains 20 red blocks, 25 blue, 28 green, 30 black, and 27 white. So we know they're probably going to ask us something about probability. A block is randomly selected from the can. Determine the probability that the block will be the following. Yellow. Now, it's impossible to get yellow because there's not one yellow block in this can. So you just say 0, right? Students sometimes get a little bit thrown by questions like this. But remember, you can have a probability of 0. It just means it can't happen. It's impossible. So don't be thrown by that. Then it says blue. So now we know that there's 25 blue, and that's what we want. And that's the whole thing with probability. What do I want? Over all the possible things I could get. So all the possible things I could get, I have to add all of those together. 20 plus 25 plus 28 plus 30 plus 27. So there's 130 blocks in total. Okay, so it's going to be 25 over 130. Please remember, and students often forget this, please remember to always simplify your answers. So put this into your calculator and put your answer, I would just leave it as a fraction. They didn't say that we had to put it as anything other than well, they didn't actually say how they wanted it. So I would just put it as a fraction. So your answer would be 5 over 26, and we are done there. Okay, I'm just going to continue in this video with 4.2.4, right? It's a slight turn of emphasis, but not beyond us, okay? And then we'll be finished with question 4 after this. The building blocks are packed into small cylindrical cans that are then packed into large rectangular boxes as shown in the diagram. So basically these oaks are packed into there. Okay, they've given us some dimensions here. Please note this is cylindrical. So what is this? This is the diameter. Okay, remember you don't have something like length when it comes to circles because there's no straight sides. You always have diameter and then height. Oh, sorry, my hair is dropping everywhere. Right, then my rectangular box, right, is going to be my length and width and height, because that's a pretty standard rectangular shape, or prism, if you want to call it that. Okay, so let's look here. The cylindrical cans are placed upright into the box. They're probably going to say how is it ordered, how many can go in, etc. So it says determine the number of layers of cans that can be placed in the upright position in the box. So basically, the cans I'm going to stack like this. That's how I'm going to stack them, and then across like that. Okay, I'm not a particularly good drawer here, but I think you know what I mean. So here we can see that the height is 16.5. So that is going to correspond to the height of the box, which is 35. So let's see how many times 16.5 goes into 35. Okay, it goes 2.121212. So now you can't say 2.1212 boxes, because that doesn't make sense, or cans, right? You can only say 2, because you either have 2 or you have 3. And there's that element of logic that comes into Mathlet, okay? So let's just move this up so that you can see. Okay, so you would say 35, as I did on the calculator, divided by 16.5, which gives you 2.1212, and you'd say that is equivalent to 2. Okay, so that is how many boxes you would put in, right? That's how many layers of cans that you could place into the box. Okay, let's now do the last question for this question. So that was A. We're now going to do B. Okay, B is a few more marks, but not impossible. It says, hence determine the maximum number of cans that can be packed into one box. Okay, so let's look here. We know that there's 2 in height, so it's going to be 2, right? Then we need to say, okay, well, how many are going to fit in that way? How many are going to fit in that way? And you could be saying, but now I don't know what dimensions I'm working with. Well, height corresponds to height. And here, diameter is going to be both its length and its width. Because remember, in a circle, right, the diameter is both ways. In a square or a rectangle, you would have length and width. So length and width in the circle is just diameter, right? So we're going to say 41 divided by 12.6. Okay, 41 divided by 12.6. And we're going to say 56 divided by 12.6, because that tells us how many cans we can fit in each dimension. So 41 divided by 12.6, that's going to give me 3.25, etc. But that's only going to be 3, because remember, we can't cut these cans in half. That's not what we're doing. Then we say 56 divided by 12.6, and that gives me 4.44, etc. But we make that equal to 4, because you can't round it up because there's not more space, and you can't keep it at a decimal because you can't cut these cans into little pieces. Okay, so my dimensions that I'm going to be timesing together are these 3. 2 times 3 times 4. Put that into your calculator. 2 times 3 times 4. And it is going to be 24 cans. Okay, so this question here is one of those ones where it requires you to use your logic quite a bit, but not beyond you, right? You should be able to see that this kind of makes sense. If you were packing these in yourself, this is how you would go about it. Right, we only have one question left of this paper, and then we are done.